In previous video, we talked about the graph of y equal to ax squared and ax squared plus c. In this video, we will learn how to graph the standard form quadratic function y equal to ax squared plus bx plus c. Now, we are familiar with the concepts of concavity, and that means whether the parabola opens upward or downward. Okay. So with this, the factor that affect the concavity is the coefficient a. So if a is positive, it's concave up, and if a is negative, the parabola is concave down. Okay. The next concept that we already learned is about the symmetry. Symmetry around the symmetric line while x equal to negative b divided by 2a. So in this case, here is where the b in the formula comes into play. Okay, so x equal to negative b divided by 2a is the axis of symmetry. Okay, so this one is the axis of symmetry. Also, we learn how to use the table of values. To find coordinates. Okay, and by finding coordinates of one side, we can actually reflect the points across the axis of symmetry to get the 2 points. You get more points on the graph. Okay, so let's do some examples. So suppose that I have the function y equal to x squared minus 6x plus 4. So the most important thing is that you have to identify the coefficient correctly. So in this case, this is a full standard form of the quadratic function. So we know that a is the coefficient in front of the x squared, right? So a is 1. B is the coefficient in front of x. But remember the sign of the number as well. So here in this case, b is negative 6. And c is 4. Okay. In this case, I can actually immediately find the vertex. Okay. X equal to negative b divided by 2a. And this equal to negative b, which is negative of negative 6. Okay. Divided by 2a. A is 1. So we have 6 divided by 2, and I have it 3. Okay. So x equal to 3 is the axis of symmetry. X equal to 3 is the axis of symmetry for the graph of, let's call this function number 1 here, so the graph of 1. Okay, now when I have x, because we need to have a coordinate, right? What happened is that also we know that a is 1, which is a is positive. The parabola is concaves up, okay, and the vertex is the minimum point, okay, minimum point. So what happened is that we need to have a x and y order pair to represent this minimum point here. Okay, so we already know that x equal to 3, and we need to find y. How do we find y? You plug x equal to 3 to the original function here, to number 1. So input x equal to 3 back to function 1, we would have y equal to 3 squared minus 6 times x, which is 6 times 3, plus 4. 3 squared is 9, minus 6 times 3, 18, plus 4. So this equal to -5. Okay, so here for my vertex, the coordinate of my vertex is x equal to 3, y equal to -5. Okay, so the vertex is 3, -5. Alright, now we would then find 2 other points on the graph, right? So here let's sketch this. We know this concave up, so alright. Alright, so the vertex is 3, -5. One, 2, 3 here. -5 here, right? So this is a vertex. Okay, the vertex point. Now, in order to find other points on the graph, we need to construct a table of values, right? So I have x here, I have y equal to x squared minus 6x plus 4, and here I have the x, y coordinate. Okay, so let's choose, let's say I choose x equal to 0. Okay, so x equal to 0, I have y equal to 0 squared minus 6 times 0 plus 4. So I have this actually equal to 4. So I have one point. I have one pair of coordinate is 0, 4. Okay. So x equal to 0, y equal to 4. Let's try x equal to 1. X equal to 1, here we have 1 squared minus 6 times 1 plus 4. And this equal to 1, 5 minus 1. Right? So x equal to 1, I have y equal to -1, right? So because we know that it's symmetry, right? Because of the symmetry aspect of a parabola, we only need to find 2 points, and then we can reflect those 2 points across the axis of symmetry here. Okay, so this one, x equal to 3, is also the axis of symmetry for the parabola. Okay, so we only have to match these 2 points, and then we can reflect across this axis of symmetry. So x equal to 0, 0 here, y equal to 4. So let's say 1, 2, 3, 4. So this point, okay, and then x equal to 1, y equal to 0. So x equal to 1 here, y equal to, y equal to -1. So -1 here, this point. Okay, alright. So we also need to reflect across the axis of symmetry. Okay, so because the reflective axis of symmetry here, we have 3, 3. So 4, 5, 6. Okay, 3 unit. So we also have to reflect to 3 units. So that means that this point would be 6, 4. Okay, and then this point here, reflect across this axis of symmetry, we would have this. So this one would be 5, -1. Alright, so how do I know? I know that the distance from this point to the axis of symmetry is 3 units, right? For this one, for this point, is 3 units. So from the axis of symmetry, I will count 3 units. 1, 2, 3 over here, okay, to get my second point. And because this is so the total distance would be 6. Okay, in this case, I know that my point is here, so x equal to 1. The distance from 1 to 3 is 2 units. So from the axis of symmetry, I also count 2 units. So 1, 2 here, and I have my second point. Okay, so the total distance from 0 to this point is actually 5 units. Okay, so once I have the coordinates, I would use I would draw a parabola for this. Okay, may take some time to actually practice. Ooh. Okay. Just a little bit missing here. Alright. Anyway, so this is the parabola of the function y equal to x squared